Good morning, guys. We're gonna continue for our series. So we're dealing with integration. Last time we did basic integration, integration by part, and now we are going to deal with what we call partial fraction and log division. Okay. Now, look at this example. Okay. Now, how to identify whether you have to do partial fraction or long division. There are three possibilities, okay? It's either the degree of the numerator is greater than the degree of the denominator, okay? Second one is when they are equal, and the third one is when the degree of the numerator is less than the degree of the denominator. So, for instance, in this case, you are looking for the highest degree. Okay, the highest degree here is 4, and the highest degree here is 3. So, these two lead you to do long division, and this one leads you to do partial fraction. So you only do partial fraction when the degree of the numerator is less than the degree of the denominator. Okay? So in this case, we're gonna use long division. Why? Because the exponent of the numerator is higher than the exponent of the denominator. Okay, good. So this is your numerator, this is your denominator. Okay? So this is how we place it. This is your numerator, and this is your denominator. Okay? So that you can. Now, how do you do the long division? I'm going to use the blue pen. You look into the highest exponent here, and you look to the highest exponent this side, and you look for which number or which function you can put here so that you can eliminate it. So here I have x exponent 4, here I have x exponent 3, which means I have to put x exponent 1 here, because if I take this, when you come this side, you multiply, okay? It's going to be x times x cubed, which is x to the power 4. When you come this side, you have to change the sign. Every time you come this side, you change the sign. It's going to give you x to the power 4, but it's not going to be positive, it's going to be negative. Alright? It's to multiply. When you come this side, change the sign. Change the sign. The sign, okay? Then you continue x times minus x squared, it gives you minus x cubed. When it comes this side, it becomes positive x cubed. Alright? There's nothing else here, so I have to compute this. If I compute this gives you 0, and this and that gives you 0, so it's going to be 0. I take this one down, x. Alright? So, you're going to check again. You check the first term here, it's x, and you check the first term here, it's x cubed. You have to stop because the degree of x here is less than the degree of x cubed. You only continue when this degree is greater than this one. Alright? So I'm gonna stop this like that. So this is my remainder. This is called your remainder. Now, how do I cope with this? Remember, I'm having x to the power 4 minus x cubed minus x minus 1 divided by x cubed minus x squared. Alright, so which means I can write it as my answer. This is your answer, right? Answer plus what? Plus the remainder, which is x minus 1 minus x minus 1 divided by the denominator, which is x cubed minus x squared. Alright? So basically it's what? How do you write it? You write the answer plus the remainder divided by the denominator. This is the rule. Alright? So in case you are doubting, let's try to prove it. Is this the same as that? We're gonna prove it. Okay? Let's find the common factor, which is x cubed minus x squared. I'm gonna take this divided by 1 multiplied by x. It's gonna give me x multiplied by x cubed minus x squared plus minus x minus 1. Okay? This one will give you x to the power 4 minus x to the power 3 minus x minus 1 divided by x cubed minus x squared. What do you see? This is the same as the original equation. So you do log division to reduce or to simplify your function. Okay? So we can clearly say this function can be written as x plus between bracket 1 minus x minus 1 divided by x cubed minus x squared. Alright, so let's continue with our. I will not do this formula anymore. Good. So I have integral of x. I want to write it like this. It's fine. It's fine with me. And then dx. Alright? So what's the next step from here? I have to do the distribution so that I can solve it. This will be x dx plus integral of minus x minus 1 divided by x cubed minus x squared dx. What I did is I just distributed this guy, right? Let's continue. What is the integral of x dx? The integral of x dx is x to the power 2 divided by 2 plus, I'm having this x minus 1 over x cubed minus x squared. So this, you can put the minus, you can factor it, you put minus outside so it's become x plus 1, but I want to leave it this way, okay? I want to leave it this way. I want to work it out like this. So, what's the next step? Here it's x squared divided by 2 plus x minus 1 divided by. Look at this, I can factor it. I can put x squared outside and remain with x minus 1. If you take x squared times this, it gives you x cubed. X squared times minus 1 u minus x squared. So our problem is here. How do I solve this equation? We go back to the rules. We say if the degree of the numerator is greater or equal to the degree of the denominator, you do what? You do long division. But if the degree of the numerator is less than the degree of the denominator, you do what we call partial fraction. Okay? So I just want to take this question and solve it. Okay? Let me call this A. No. Let me call it I. Okay? I'm going to solve this question. I call it I. So I'm having x minus 1 divided by x squared x minus 1. I am not sure if this space is going to be enough for us to finish up, but yeah, I'll try to squeeze it. Okay, now in this format, you clearly see that the degree of the denominator is greater than this one, so I'm going to do what we call partial fraction. Okay, Snake partial fraction. Now, how do you separate it? This is a nice topic. I'm gonna try to give you the theory behind it. Okay? There are 3 scenarios, okay? When you have a linear, what you call, just give me a minute. Linear function. When you have your book at page 33, a linear function, and when you have this kind functions, let's say if you have x divided by x minus 1, x plus 2, like this, and x minus 5, for instance, like this, you separate them as a divided by x minus 1 plus b x plus 2 plus c x minus 5. This is the first category. Okay? The second category is when you have something which repeats. For instance, like this. When I have x divided by x minus 1 all to the power 3. This one you separate them as a divided by x minus 1 plus b divided by x minus 1 squared plus c x minus 1 to the power 3. And then the last one, it's when you have a quadratic one, or when you have a non-linear or quadratic. A non-linear is like this: x divided by x squared plus 2, for instance, or plus 1. If I have something like this. If you have something like this, I just want you to see the difference. Like this, I want you to see the difference. Okay? When you have a case something like this, x squared plus 1 equal to 0, x squared equal to minus 1, x squared equal to plus or minus square root of 1. Okay? And then you know that I squared equal to minus 1. So basically I'm going to have x squared, x equal to plus or minus I. Alright? So every time you get your answer which doesn't belong to R, okay, you have to use what we call a nonlinear factor. This is called a nonlinear factor. Nonlinear. Okay? So how do you use it? You put a x plus b over that factor. Alright? But look at this one. I have x squared minus 3. Okay? This one will equal to 0. X squared will be equal to 3. X squared, x will be plus or minus square root of 3. These are distinct answers. Okay? So I can write this as x plus square root of 3 and x minus square root of 3. This one you can write it as x plus I, x plus minus I. The moment you see I, you have to use this factor, x plus b. Alright? But here, in this case, when I have two distinct numbers, what I have to do, I must not leave it like this. It will become like this, x divided by x squared plus 1. And then I have to separate this like this. Okay? Then I can claim the first part will be a divided by ax plus b divided by x squared plus 1. The second part will be a. Actually, you have to change. You can put c here, x plus square root of 3 plus b, x minus square root of 3. Alright? Good. Now, let's continue. I have to separate this one. I'm having this x to the power 2. There is two ways to solve. I can claim that this one is a repeater, or I can claim it as it's a quadratic. When it's a quadratic or non-linear, you use this formula. Alright? So let me say that x squared is a repeater. So I can write it as a to the power x plus b to the power x squared. Alright? Plus c divided by x minus 1. Because this one is a linear. A linear is when you get directly your answer. A distinct answer, right? You have 1 in this. It's a linear function. Okay? So this is how I separate them. The next step will be to find the common denominator. I have minus x minus 1, x squared, x minus 1 equal to. I have to find the common factor, which is x squared, x minus 1, right? It's going to give me this divided by x multiplied by a. I'll end up having ax x minus 1 plus this divided by this is going to give you only this, going to give b x minus 1. This divided by this, it will give you x squared, so you will have cx squared like this. Alright? You can change this guy. Right? Basically, it's me. I multiply this whole thing by x squared x minus 1. So if I multiply both sides by x squared minus 1, it means the denominator will fall off. Okay? So I remain with what? Minus x minus 1 equal to ax squared. I'll copy it like that first. Ax times x minus 1 bracket plus bx minus 1 plus cx squared. Alright? So let me remove the bracket. I'm going to have x minus 1 equal to ax squared minus ax plus bx minus 1 minus b. Alright? Plus cx squared. Alright? I'm just double checking them. Alright. So, the next step will be to group them. Minus x minus 1 equal to, I have the term with x squared here, I have the term with x squared there. So it's going to give me a plus c x squared. Alright? I have the term with let me take the red pen. Take the red pen. I have the term with x and I have the term with x here. So look at the way I like to write it. I like to add them with a positive and then I copy them as they are. A plus b x like this. Alright? And then I have my independent term which is minus b. Alright? What is the next step? I'll have to remove this part, unfortunately. So, from here, we're going here. The next step will be identification. Identification. Alright? So we start with the term with x squared. On the left side, I don't have the term with x squared. But on the right side, I have a term which has x squared. So it's going to be a plus c, okay, and then 0. Okay, let me write it as it is. On the left side, I have 0. On the right side, I have a plus c. Alright? Then the next step will be the term with x. On my left side, I have minus 1. And then on my right side, I have minus a is plus b. And then the independent term or the constant, independent term, on my left I have minus 1. And then on my right I have minus b. Alright? So, from here, you can see b equal to 1, okay? You take this 1, you put it this. Okay, this is 3, this is 2, this is 1. From 3, you can see b equal to 1. You call this 4. You take 4, 4 in 2. It will give you what? Minus 1 equal to minus a plus 1. Because b equal to 1, I replace b by 1, it's give you 1. And then what do? I must solve for a. A will be equal to what? A will be equal to 2. I'll take this one, come this side, and I'll give you minus 2. And then you have, let me just write it, it's going to be minus 2 minus a. So a will be equal to 2. So this I call it 5. And then you take 4 and 5 in 1. It will give you what? Although you take only 5 in 1. 5 in 1. 5 in 1. So it's a plus c equal to 0. And you know a equal to 2, so c will be equal to minus 2. Alright? Then I have minus x minus 1 equal to x squared x minus 1. The value of a is equal to what? 2 over x plus the value of b is what? 1 x squared. And the value of c is equal to what? Minus 2 x minus 1. So I'm having this. When they mark this one as 1, all this as 1. And then when you get A, B, C correct, they give you 1 mark, 1 mark, 1 mark. Okay? This is how they mark it. Now, the last step will be to integrate this function. Okay? I'll try to integrate it quickly using this small space. Okay? It's gonna give you 2 ln of x, alright? And this one, I want you to pay attention here. You know the first step is when you are solving it, you have to distribute it. It's going to give you 2x dx plus 1 integral of 1, which is dx over x squared, and then you have plus minus 2 dx over x minus 1. Okay? So this one directly gives you 2 ln of x, and this one you have to take it, you have to do it this way. It's going to give you x to the power minus 2 dx, alright? So you use your rules, your power rules. It's going to give you minus 2 plus 1 over minus 2 plus 1, which is x to the power minus 1 over minus 1. This, you don't leave it this way. You have to write minus x to the power minus 1, but you don't leave it this way. You have to write it properly as 1 minus 1 divided by x. Alright? So that's what I'm going to put right here. It's going to give you minus 1 divided by x. Alright? Now, this one will give you what? Minus 2 ln of x minus 1 plus c. I know this question is very long because we use long division and partial fraction combined. And most questions in your test or exam, They won't give you a direct question like solve using, for instance, integration by part, and then you solve it, you just use integration by part only. No, 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 no. When you're gonna solve integration by part, you'll have a term that will request you to do either long division or partial fraction. Alright? So you have to know all the concepts. You have to know when to use partial fraction, when to use long division, and when to use integration by part. You have to know all of them. Alright. For today, I can stop. I'll stop by here. And then I'll do the same question. I want to do the same question. And then I want to separate it differently. Okay, I'm going to take the same question and I'm going to separate it differently, and I'll see if we're going to end up having the same result. Alright? Okay. Where's my... Alright. Remember, this question was only for I, which means the final answer will be x squared divided by 2 plus this. Alright? So let me do some transformation right here. Yes, I'm having minus x minus 1 divided by x squared, x minus 1 minus dx. Now, in case, because we said a non-linear or a quadratic, you have to use x plus b, and then you put that term, that factor in the denominator. So if I decide to separate them as ax plus b divided by x squared, okay, and then I put plus, I have this term which is x minus 1. So I give you a divided by x minus 1, like this. If I decide to separate them this way, will I be correct? Remember, I said when we have a non-linear function, basically is those functions you end up having a complex number, okay? Those ones you end up having a complex number. You separate them ax plus b, alright? Or if you have a quadratic equation, you can do it this way. Alright? Let's find out if you're gonna get the same answer. Let's see. Here it's going to be minus 1 minus x minus 1, x squared, x minus 1. This is going to be x squared, x minus 1. This divided by this is giving you ax plus b, x minus 1, plus this divided by this is going to give you x squared, alright? Then from here, I multiply by x squared, x minus 1. So it's actually cancelled out on this, alright? Then I have minus x minus 1 equal to, please, I want to multiply it directly so that I don't have a lot of lines. So I do ax squared minus ax plus bx minus b plus a squared. Alright? So I'm going to try to group them. It's going to give me x squared here. Sorry, there's a mistake. I already used the letter A here. I cannot use the letter A again here. So let's find another letter. Let's call it P, for instance. P, alright? P. Call it P. Alright? So I will have A plus B x squared, and then the term of x will be plus minus A plus B, and then I will have what the independent term is B only. Alright? I will definitely erase this. I'll definitely erase that, and then I will have what? Identification, ID. In terms of x squared, on the left side I have 0, on the right side I have A plus B. Alright? In terms of x, on the left side I have minus 1, on the right side I have A plus B. Alright? Independent term, on the left I have minus 1, on the right side I have minus B. Alright? Basically, I'm having the same thing. So here I'm having B equal to 1. Here A will be equal to 2. And here P will be equal to minus 2. Alright? Now, let's put it back to the equation that is equation. Are we going to get the same answer? I'm having ax. A is 2. It's going to be 2x plus b. What is your b? Your b is 1 divided by x squared. Alright? Plus p. Your p equal to minus 2. Plus p, which is minus 2, divided by x minus 1. Alright? Everything should be ax. Alright? From here, I must distribute. It's going to give you what? Look, this plus 1 divided by x squared dx plus integral of minus 2 x minus 1 dx. Alright? This, you can separate them. This will be 2x divided by x squared dx plus 1 divided by x squared dx plus, I can take minus 2 in front of integral sign, it will be like this, and then x minus 1. Okay? You can clearly see this one cancel out. X cancel out with this. So you have ln of 2, you have 2 ln of x, 2 ln of x plus this integral. It's exactly as this one. So it gave us minus 1 over x, alright? And this one is minus 2 ln of x minus 1 plus c. If you look at those answers, they are the same. Alright? So that was partial fraction and long division. Yeah.